Alright, so let's calculate x-intercepts. So when we're talking about x-intercepts, let's define what they are before we actually do any calculations. If I'm trying to find an x-intercept, what I'm really wondering is that if I had some random parabola like this, and I wanted to know what the x-intercepts are, I'm basically talking about these points right here. I'm saying there's points on the x-axis. This graph's crossing the x-axis 2 times, and I want to know what those points are. And so for this one, I can say it looks like negative 2, 0, and it looks like there's another one over here at negative 8, 0. And I would say those are the x-intercepts. So if you notice what both of these points have in common is that if I was looking at an x comma y, that both of them in the y spot, there's a 0, right? So it's always something comma 0. If it crossed somewhere else, like if it crossed over here instead, I would say, well, this one looks like it's at about 1, 2, about 2.5 comma 0, and this one's way over here at 3, 4, 5, 6 comma 0. So there's still, again, it doesn't matter where that parabola is, there's always a 0 in the y location. And that's going to be the key for us to calculating an x-intercept. I know that all x-intercepts look like this, and there's always a 0 in the y spot. So what I'm going to do when I want to calculate is put a 0 in the y spot. And then I'm going to write the rest of it, and if you notice, this now looks like what we solved when we were doing factoring, the square root method, and the quadratic formula. This is a factorable expression. I can say 4 times 3 gives me 12, 4 plus 3 gives me 7, so I can solve this by saying this is the same as x plus 4 and x plus 3 is equal to 0. Okay? And then I can set each of these factors equal to 0, and I can say, well, that means that either x plus 4 has to be 0 or x plus 3 has to be 0. And that's going to give me two values. I get x is equal to negative 4 and x is equal to negative 3 when you go through and solve these. And so I'm going to say there's two x-intercepts here. This graph, if I were to graph this function, crosses the x-axis at two places. It crosses at negative 4, 0 and at negative 3, 0. Right? So if I were to kind of just to take a look at those points, I would say the graph's going to be this really skinny looking graph that maybe looks something like this. Right? But I know that it's going to cross those 2 points right there. Okay? So just as a reminder for x-intercepts, that f of x and y really mean the same thing. So if you're trying to plug in a 0 into the y location and it looks like function notation, you can get rid of this entire f of x and just put a 0 right there, and then it's going to work out exactly the same. And I'm going to say this is a factorable expression. I can solve this now because I have a 0 instead of a y. And I can say this also factors into x minus 5 and x plus 4, and that equals 0. And because I now have factors equaling 0, I can say each of those could be 0. So I can set that equal, the first one equal to 0 and to the second one equal to 0. And I can solve each of these. So if I add 5 to both sides, I get x is equal to 5. That's a x-intercept. And when I subtract 4s, looks like I get that x is equal to negative 4. So again, I get two x-intercepts. I get the point 5, 0, and I get the point negative 4, 0. And I would say that if I were to graph this parabola, it's going to cross the x-axis at these 2 points. Okay? Y-intercept is similar. Right? I'm going to plug in a 0 again, but instead of plugging it in for y, I'm going to plug it in for x. Because again, if I were to take a look at the graph, right, a standard graph, I'd say y-intercepts are always going to be these points that are crossing the y-axis. And if I were to figure out what all these points look like wherever they are, it's always like, for example, 1, 0, 2, 0. Oh, I'm sorry, let me fix that. 0, 1, 0, 2, 0, 3. So it's always 0, some y value. There's always a 0 in the x location. So I'm going to say, if I plug a 0 in for x, I'm going to figure out what that y is. So that's all we have to do to calculate a y-intercept. And I'm giving you a nice little hint here. When it's in standard form, it's always just going to be the c value, because watch what happens. If I say, let's leave y alone now, and I'm going to put a 0 into these places here, it's going to be 0 squared plus 7 times 0 plus 12. Well, 0 squared is 0. 7 times 0 is also 0. And I get a 12. So I'm saying it's really 0 plus 0 plus 12, which is just 12. So I'd say this is the point, so my y-intercept is the point 0, 12, which is really just the c value. Okay? So a nice little shortcut for finding the y-intercept is just take a look at this value. if I did it without plugging in, right, the idea is that we want 0 in these x spots. All of this is basically going to become 0, and I'm going to say that this one has a y-intercept of 0, negative 20. Right? So that's a nice little shortcut to use. Instead of having to do this calculation, I can just know that these are going to turn into zeros and say I get a negative 20 out of that. Right? So now that we know how to find the 5 key points, in the next video we're going to actually calculate all of them and put those onto a graph and see what our parabola looks like.